Greetings, my favorite factors. Max's Math Magic here. We're going to learn how to solve quadratic equations by factoring. So what we're looking for is something of this form right here, where we have an x squared and an x and then a constant. It doesn't have to be x, of course. It could be whatever variable we happen to be working with. It could be t, it could be p, it could be theta, the Greek letter theta. But what we want to do is solve these things by factoring. In other words, what number times itself, in other words, what number squared, plus 7 times a number equals 18. That's the overall question that we're asking here. Now, one thing that we want to do is make sure that these are always set equal to 0. So I'm going to subtract 18 from both sides. And so I get x squared plus 7x minus 18, and that is set equal to 0. At any rate, how do you factor these things? Well, I want to look for numbers where they multiply to give me negative 18, but they add up to give me positive 7. And if you think about the factors of 18, there's 1 and 8. That's not going to work. There's 2 and 9. And hey, 2 and 9, that can give you a 7. So I'm going to put a 2 here and a 9 there. And then we have to figure out, does a plus go in between these or a minus, or maybe they're both positive, maybe they're both negative. And in this case, we get a negative 2 and a plus 9 there. So the reason why I want to set this equal to 0, and you always have to set these equal to 0, is because there's this property called the zero factor property. It says if two real numbers are multiplied together, so a times b, I'm using the dot for multiplication in this. If a times b equals 0, then we can conclude by saying a equals 0 or b equals 0. One of these two factors has to equal 0. And that is unique about the number 0. It's not true for the number 18. If I said if a times b is 18, then one of these two things has to be 18. Why is that not true? Well, 2 times 9 is 18. And so those are two numbers that multiply together. They're not 18, but they give you 18 when they multiply together. So 0 is a very unique number in that sense, that when two things are multiplied together, two real numbers are multiplied together and they give you 0, one of those two real numbers has to be 0. And we know that these two things stand for real numbers. And so either x minus 2 equals 0 or x plus 9 equals 0. And those are two pretty easy equations to solve. I can add 2 to both sides, and I get x equal to 2. Or I can subtract 9 from both sides here, and I get x equal to negative 9. So these right here are my two solutions. I can also write them as a set, negative 9, 2. If I wanted to. That's called your solution set. Now, it's always a good idea to check your work. I'm going to go ahead and do it with the number negative 9.
You've reached a checkpoint.
So I'm going to plug negative 9 into the original equation that I was given and see if I get 18. Negative 9 squared plus 7 times negative 9. And I'm going to hope that that equals 18. So I'm going to say that's equal to, with a question mark above it, because I don't know that that's going to equal 18. I'm going to check that. Well, negative 9 times negative 9 is positive 81. 7 times 9 is 63, and it's a positive times a negative, so it's minus 63. And you can verify that 81 minus 63 is, in fact, 18. Check.
You have reached your destination.
So you can do the same thing for 2. Plug 2 into the original equation. On the left-hand side, you'll get 18, which is what you want it to equal on the right-hand side. All right, so let's try this one. I want to find out what number squared minus 8 times that number equals negative 9 minus 2 times that number. Again, I need to make sure that this whole entire thing is set equal to 0. Add 2t to both sides, and also add 9 to both sides. I have a t squared. Negative 8t plus 2t is negative 6t. There's no constant here. There's a 0 there, which I guess is a constant, but 0 plus 9 is 9. And that's set equal to 0. I moved everything that was on the right-hand side over to the left-hand side. Now, if you watch the video on factoring trinomials, you'll recognize this as a perfect square trinomial. This factors as t minus 3 quantity squared. Or in other words, t minus 3 times t minus 3 equal to 0. And you'll notice that we only really have one solution. It's technically two solutions, but it's repeated. In the biz, we call those the multiplicities of the roots, and so we would say that 3 has a multiplicity of 2, meaning 3 is a solution twice. So I would say t minus 3 equals 0, or t minus 3 equals 0. A little redundant, but we get t equal to 3 both times, and so there's our solution, or as a set, we get that right there.
Game over.
So hopefully you're getting the hang of this. Let's try another problem. Let's try 3p squared plus 5p equal to 12 plus p squared. Well, again, get everything on one side of the equation. So I'm going to subtract p squared from both sides. I'm also going to subtract 12 from both sides. 3p squared minus p squared is 2p squared plus 5p minus 12. Everything on the right went away, and so that's set equal to 0. Now the leading coefficient is not a 1 anymore, and so I need to use what is called the AC method. Again, link in the description below for factoring trinomials that don't start with a 1, that don't have a leading coefficient of 1. So what I do is I multiply a and c together. What do I mean by that? A is the number in front of the squared term, c is the constant all by itself, and so a times c is negative 24. 2 times negative 12. So the goal and the task before us is to figure out what factors of negative 24 will add up to 5. Okay, again, there's a whole video on this. I'll just go through it real quick. 1 and 24, not going to give me 5. 2 and 12, not going to give me 5. 3 and 8, 8 minus 3 is 5. And so that's the winning combination. 2p squared plus 8p minus 3p minus 12 equal to 0. Again, I got 8p minus 3p by looking at the factors of negative 24 and seeing what added up to give me positive 5. Well, now we can factor this by grouping. And in the AC video, we talked about grouping, and there's a video about factoring by grouping all by itself that's also linked in the description below. I look at these two terms and I ask, what do they have in common? I can pull a 2 out of both of them. I can pull a p out of both of them. So when I pull a 2p out of 2p squared, I'm left with a p. When I pull a 2 out of 8, I'm left with 4. When I pull a p out of p, I'm left with 1. So 4 times 1 is 1. Let's do the same thing for these two terms. What do they have in common? They both have a negative 3 in common that I can pull out. When I pull a negative 3 out of negative 3p, I'm left with a p. When I factor a negative 3 out of negative 12, I'm left with a positive 4. That's still all set equal to 0. And this should always happen, where you can now factor this out of these two different terms. And so that's how factoring by grouping works. And you know that this will work if you've done your AC method correctly. So p plus 4 times, if I pull a p plus 4 out of here, I'm left with a 2p. If I factor a p plus 4 out of here, I'm left with a negative 3. And that is set equal to 0. I use my zero factor property. Either p plus 4 equals 0 or 2p minus 3 equals 0. Pretty straightforward to solve for. Here, subtract 4 from both sides, I get p equal to negative 4. Or if I add 3 to both sides here, I get 2p equal to 3. And to undo this multiplication of 2, I divide both sides by 2, and I get p equal to 3 halves. Nothing says that these have to be integers. We got a rational number here. We got 1.5, or 3 halves, and we got negative 4 for our answers. I got 5x plus 50 equal to 6x squared. What number times 5 and then plus 50 will equal that number squared multiplied by 6? What I'm going to do, I like my leading coefficients to be positive. So as a personal preference, I'm just going to subtract 5x from both sides, and I'm going to subtract 50 from both sides. I just prefer having my leading coefficient being positive. So 0 equals 6x squared minus 5x minus 50. The leading coefficient is not 1, so I get to do the AC method. AC is 6 times negative 50, which is negative 300. Now, there are a bunch of factors of negative 300. And I'll just get to the point. 1 times 300 isn't going to work because I'm looking for a 5. 2 times 150, that's not going to work. 3 times 100, those are not going to add and subtract to give me a 5. All right, so there's a bunch that I'm going to try. The winning combination is 15 times negative 20. 15 times negative 20 gives you negative 300, and these two numbers add up to give you negative 5. So that's what we're going to put here. So 0 equals 6x squared plus 15x minus 20x minus 50. I rewrite my negative 5x as 15x minus 20x, and the 15 and the minus 20 came from the fact that they multiplied together to give me negative 300, which was my a times c. I factor by grouping. I ask myself, what do these two have in common? Well, they certainly have an x in common, but they also have a factor of 3 in common. So I'm going to factor a 3x out. In doing so, I'm left with a 2x right here and a 5 right there. I need to figure out what these two terms have in common. There's a negative 10 that I can factor out, and that's about it. They don't share a factor of x in common. And so when I do that, I'm left with a 2x right here. When I factor negative 10 out of negative 50, I'm left with positive 5. And I've done my factoring by grouping correctly because they each have a 2x plus 5 in common, which I can factor out. And I'm left with 2x plus 5 times 3x from here, negative 10 from there. And again, by the zero factor property, either 2x plus 5 equals 0 or 3x minus 10 equals 0. So subtracting 5 from both sides here, I get 2x equal to negative 5, and so x is negative 5 halves. Or here, I add 10 to both sides. I get 3x equal to 10, divide both sides by 3, and I get x equal to 10 thirds. So I get two fractions. I get two rational numbers in this example. Negative 5 halves, 10 thirds. Oh, excuse me, teacher, I think you forgot to assign us homework. Hey, thanks for reminding me. I almost let you go without giving you a homework assignment. You're only going to get good at this if you practice, practice, practice. And so here are 4 problems for you to practice. There are answers to those problems in the description below. So go ahead and try these out. Check your answers to make sure you get what I get. Practice even more of these problems. Go through the problems that I do and try them on your own. Thank you for joining me. Hit that like button, hit that subscription button if you haven't already, and I'll see you next time.